Good morning, all.
Good morning, sir.
Then today's class is basically based upon the concepts of epsilon NFA or the NFA with epsilon moves. But before that, I am moving for the previous class. I am starting from there and I will move for the NFA with epsilon moves and how to convert those NFA epsilons into DF. Then going for the previous class, I think all of you have remembered that we have gone for the regular operations. Have you remembered or not? And as I am saying,
Yes, sir.
be interactive.
Yes, sir.
Then here a picture is there to you, you can see. Is it visible to you?
Yes, sir.
Yes, sir.
Here I have gone for 6 pictures. The line number 1, that is the first 2 pictures, representing union of 2 regular languages. Line number 2, representing the concatenation of 2 regular languages. The third one is representing the third row, that is the next 2 pictures, representing the clean star of 2 regular languages. Then going for all this, yesterday whatever I have explained you, you can see that is there in the diagram. Yes or not? जो भी समझाया था डायग्राम में है कि नहीं?
Yes, sir.
But one thing you can see that what is the difference I am saying, that in this figure for union I have gone for 2 figures, but yesterday I have explained you one. Here I have added a new one. Okay, here I have added a new one. You can see. Are you getting it? What is the new here?
Yes, sir. The final state, the new final state.
Yeah. That is, whenever I have gone for the yesterday's class, तो जो लोग लेट में आ रहे हो वो लोग टाइम पे आओ, वो बीच में डिस्टरबेंस हो रहा है, कुछ समझाते वक्त बीच में आ जा रहे हो. And going for the picture, you can see this is the diagram that I have explained you yesterday. My mouse cursor is visible to you.
Yes, sir.
Yes, sir.
Just wait, many of you are coming here. Then whatever I have discussed yesterday, that was the concept that if two automatons are there, first one N1, second one N2, then create a new initial state and join the initial of both with epsilon. That was the concept I have discussed yesterday. But here one thing you can see that there are two final states. But to avoid the problem of multiple final states, I have gone for this design, the left hand side design of first one. That here I am saying that the number of final states I am making here 1. That means from all the final states I am joining with epsilon transition to a newly created final state. That is the concept. Similarly, in the second case, here I have combined the final state of the first automaton with the final state of the, with the initial state of the second automaton, and I have got this. And for the spleen closure also, multiple final states are combined into a single final state with epsilon transition. These are the concepts that we have discussed yesterday. And from this, we can conclude that the finite automatons are closed under various regular operations like union, concatenation, Kleene star, complement, reversal, set difference, homomorphism, and inverse homomorphism. Under these operations, the finite automaton is closed. And whatever I am saying, that is the discussion of the previous class. And asking you any doubt from your side, you can ask anyone from your side. No doubt at all?
No, sir.
Okay,
No, sir.
thank you. Then I'm moving for the discussion of today's, that as I told you, today's discussion is about the NFA epsilons and how they can be converted into the DFS. Then going for that concept,
Good morning, sir.
good morning. Going for that NFA epsilons, I think you have remembered what do you mean by a NFA epsilon we have gone for. What do you mean by a NFA epsilon? Jyotish, please answer.
Without any input, you can transit from one state to another state.
With the value of epsilon.
Yes, sir.
Don't tell without with any input. Tell with epsilon we can transit from one state to other. In that case, if a NFA contains this type of transition, that is called a NFA with epsilon moves. Okay. Then
Yes,
the
sir.
next thing is how to go for converting a NFA into DFA where the epsilons are present or epsilon transitions are present. For that, we have to study a concept known as epsilon closure. Then first of all, give a heading, epsilon closure. What do you mean by that? I am going for it. What do you mean by epsilon closure? Give a heading and write a single line for the definition of epsilon closure. Epsilon closure of a state is the state itself along with other states that are reachable from the state on a series of epsilon transitions. Okay, epsilon closure of a state is the state itself along with the other states that are reachable from the state on a series of epsilon transitions. Got the definition? What do you mean by this? In a finite automaton, if I am finding the epsilon closure of any state, then the state along with the other states which are reachable from it by providing input only epsilon. That is called the epsilon closure. Then how to find it out? I will go for the examples also. These are the steps for converting NFA epsilon into DFA. And here it tells us that the first work is to find out epsilon closure. Then I can go for the other steps. Then how to compute the epsilon closure? I am explaining that with the help of an example. Then let this is a NFA. This is a NFA or DFA?
NFA, sir.
NFA.
How you know? How you can justify it?
Sir, because from epsilon it is going from Q0 to Q1 with epsilon
Then
in.
so is not
It
it
is
possible
single
in
input.
DFA?
No, sir.
Is
not.
not it possible in DFA? In
No, sir.
DFA, epsilon transitions are not allowed. As
Allowed.
this is containing epsilon, yeah, I'm listening. In DFA, epsilon transitions are not possible. This is having a epsilon transition from Q0 to Q1, hence it is a NFA with epsilon transition. Okay. Then how to find out its epsilon closure? Then as per the definition, I told you, what was the definition I told? If I am finding the epsilon closure of any state, that means the state itself and the states which are reachable from it with a value of epsilon. Then moving for the question, I am saying, if I am finding out the epsilon closure of Q0, then what is the state itself? Tell me.
Q0.
Q0.
Partha, wait, I'm asking the person, you or she will answer. Partha Sarathi Malik. Those who are present here, be
Yes, sir.
sincere to be present. Partha,
Yes,
okay.
sir.
As I told, the definition of epsilon closure is the state itself and the state which are reachable from it with the value of epsilon. Then for the Q0, what will be the epsilon closure?
Q0.
Q0, the state itself. Then what are the other states which are reachable
Q1,
from
Q2.
it with a value of Q1, Q2? Anything more?
No, sir.
Very good. Then starting with Q0, I am saying the state itself, that is Q0. And what are the other states that I can reach with epsilon? From Q0, providing a epsilon, I can reach Q1, and providing a epsilon, I can reach Q2. And hence, if I am finding out, have you drawn the figure in your copy?
No, sir. No, sir.
If not, then draw it. Whatever I am saying, please copy it into your copy. Don't wait. That means here the state Q0's epsilon closure indicates that the state itself, that is Q0, and the other states Q1 and Q2, which are reachable from Q0 with a value of epsilon. Both of the states Q1, Q2 combined with Q0 gives you the epsilon closure. Then moving for the epsilon closure, you can see what is the epsilon closure of Q0. Q0, Q1, Q2. Within a pair of braces means I am saying this is a particular set. Similarly, if I'll go for finding the epsilon closure of Q1, Nihar? Nihar,
Yes, sir.
what is the epsilon closure of Q1?
So Q1 itself.
Q1 itself, then anything more?
No, sir.
Very good, thank you. Then Q1 is the state itself and state reachable from Q1 with epsilon. You can see from Q1 there is no epsilon transition and hence Q1 is the only state to be present in its closure. That is epsilon closure of Q1 is Q1 itself. Similarly, going for other states, epsilon closure of Q2 is Q2, epsilon closure of Q3 is Q3, and epsilon closure of Q4 is Q4. Now you got the meaning of what do you mean by epsilon closure? Or anyone is having any doubt?
Got it, sir.
Then, moving next. Again, I am returning back to the steps. The step number 1 tells you that if you have a NFA epsilon, then find out the epsilon closure of the states. Then step number 2 tells you that find the states for each input symbol that can be traversed from the present. That means the union of transitions values and their closures for each state of NFA present in the current state of DFA. Then what do you mean by this? What do you mean by this? And also I'm going for two or three number of steps. That is, if we found a new state, take it as current state and repeat the step number 2 again. And what is meaning of this? I'm going for explanation. This is the NFA epsilon I have. I want to convert it into DFA. And for that, first step is I found out the epsilon closure. Then moving next, I'm going for the transition. That is the step number 2 and 3. I'm explaining how I am finding it this transition. Thus, rule number 1 I am saying, try to remember. Whenever I am converting a NFA epsilon into a DFA, the initial state of the DFA is the epsilon closure of the initial state of NFA. Repeating again, the initial state of the DFA is the epsilon closure of the initial state of NFA. Now here, what is the initial state of NFA?
Q0.
What is the initial Q0? Then what is its epsilon closure I got?
Q0, Q1, Q2.
And that is the state of the DFA. Got it? That is the state of the DFA, which is the initial state of DFA. Now moving here, you can see the epsilon closure of the initial state Q0 is Q0, Q1, Q2. And now this is the initial state of the DFA. And for easy convenience, I'm renaming it as A. I'm renaming it as A. And also these renaming concepts we have used before classes. 2 classes before I have used this renaming concept. And basically why I am renaming to make you know that here Q0, Q1, Q2 is a single state in DFA. But if I'm going for NFA, these are different. Now, I got a new state A, and this A is the initial state for the DFA. Then, how to find out the transitions? The transition rule I am saying. That is written in the step number 2 here. The transition rule tells that if I'm getting a state of DFA, this is the state of the DFA, then find the transition of this state with the input symbol, and what is the resultant state you are getting, find its epsilon closure. Repeating again, to get the transition of a state with an input symbol in the DFA, then go for the DFA state with the input symbol, and whatever resultant state you are getting, find its epsilon closure. And that will provide you the new state. You will repeat this process until you are getting a particular new state as a resultant state. That for every input symbol, transit from the DFA state to a resultant value and find its epsilon closure to get the state of the DFA. If you don't have understood, then understand here. Here I am getting a state Q0, Q1, Q2, and I also have renamed it as A. You may not rename it, that is up to you. Then del dash of A0. What do you mean by that? I have renamed this A from Q0, Q1, Q2. That means epsilon closure of del of A comma 0. A comma 0 means Q0, Q1, Q2 comma 0. What is Q0, 0? See the diagram, tell me. Q0, 0 is? Reply.
5.
Q0, 0 is 5. That means del of Q0, 0 is 5 here. Now, del of Q1, 0 is?
Q1 0 is Q3.
Q3.
Q3. Now I got here Q3. Similarly, del of Q2, 0 is? Del of Q5. That is 5 union Q3 union 5. Then what is the result?
Q3.
Q3. That means here I will find out epsilon closure of Q3. That is the Q3 itself, because here I have found out all the epsilon closures. You can see epsilon closure of Q3 is Q3. And this Q3 is a new state in the DFA. Q3 is a new state in the DFA. And that's why I have renamed it as B. Okay.
Okay, sir.
Here I have missed the del symbol. You can go for it. Here there is a del and here there is a del also. Symbols I have missed. Then going for similarly the extended transition of A1. This del dash, what do you mean by del dash? Have you remembered or forgotten? Del dash का मतलब क्या होता है? Extended transition. Del dash का मतलब होता है extended transition. Then going for del dash of A1, I'll find out epsilon closure of A क्या है? Q0, Q1, Q2. That is del of Q0, Q1, Q2, comma A. Similar way, Q01 is
5.
5. Q11 is
5.
5.
Q21 is
Q3.
Q3.
That is 5 union Q3 is equal to Q3. And now I am going for epsilon closure of Q3 and getting the same result Q3. Here I am not getting a new state. I am getting the same B state as before. And whatever I found out, I am designing with a DFA, which is a partial one, not completed, incompleted DFA. That is, I got a state A with a 0, I am going to this B, with a 1, I am going to this B. Is it visible? You can understand this?
Yes, sir. Visible.
तो समझ पाए?
Yes, sir. समझ गया.
किसी को कुछ पूछना है? Any doubt from anyone?
No, sir.
No. Okay, very good. Then moving for the next progress. The first step over, I got the initial state here. As I told you, initial state is the epsilon closure of the initial state of NFA. Then I have gone for the transition of values. I got a new state B. Then move. What is the new state I got? B. Then again I have to find out the transitions for B. For finding the transitions for B, these are the steps. B with a 0, that means epsilon closure of Q3 with a 0. What is Q3 with a 0? 5. And let I am giving it a new name D as a dummy state, because all of you know that 5 state means dummy. Similarly, going for B with a 1, that means a Q3 with a 1. Then del of Q3 with a 1 is Q4. Finding out the epsilon closure of Q4 is, here you can see, the epsilon closure of Q4 is Q4 itself. And as this is a new one, this state was not before, you can see the first state I got Q0, Q1, Q2, named it A. Then I got a state Q3, I named it B. Now I'm getting a Q4, that is I am naming it as C. D is the dummy state. That means if I'll provide 0 or 1 with 5 state, then it will go to the 5. That is 5 with a 0 is 5, 5 with a 1 is also 5. And that's why I have not gone for each transition. I'm going for the state C. Going for C with a 0, it means epsilon closure of del of Q4 with a 0. You can see in the diagram what is Q4 with a 0? 5. That means it is going to the state D. And similarly, Q4 with a 1 is 5 and epsilon closure is 5 itself. That is going to T. That means now again I am designing it. B with a 1 I am getting C. B with a 0, here you can design a dummy state, but here I have neglected the dummy. You can consider, it's a good approach to consider dummy, not a bad approach. It's a very nice approach that you consider dummy. That with a 0 from B, I can go for this dummy state. That is D. From C with 0, 1, I can go for a dummy. That is the same dummy state D you can design. You can move a transition B with a 0, C with 0, 1. And dummy with a 0, 1, it is staying in the dummy. And final DFA, I have designed this one is the final DFA. Any doubt from your side? Any doubt from your side?
No, sir.
Others? I'm getting only reply
Last
from
page.
Jyotish and Asutosh. Huh?
So थोड़ा लास्ट पेज
Asutosh,
दिखाए, थोड़ा लास्ट पेज दिखाइएगा 28 नंबर पेज.
दिखाया हूँ.
Yes,
Others? What about others? Rahul Senapati.
यस सर.
कुछ डाउट है और समझ गए?
नो सर, समझ गए.
Okay, very nice. Then, if you have understood, then now it is your turn. Go for this design. Find out its DFA. Be quick. 2 minutes. I will ask individually.
सर वो
Then
वाला
what is the
लास्ट सर.
ये वाला?
नो सर वो 28 नंबर.
ये वाला?
हाँ
Finished? अभी
नो सर
Can
बस
I
थोड़ा सा
जब मैं बोल रहा हूँ उसी टाइम में लिखने का कोशिश करो. Then the next question is convert the following NFA epsilon into DFA. Convert the following NFA epsilon into DFA. And this is the question. और एक चीज यहाँ से टापो मत, खुद बनाओ, तब जाके प्रैक्टिस बढ़ेगा. Please design these questions DFA. Be quick.
सर ये 0 1 2 है इनपुट या
तुम एक DFA देख के उसका अल्फाबेट सेट कैसे डिसाइड करते हो? उसमें जो भी इनपुट्स है, यहाँ पे इनपुट्स क्या है? 0 1 2. और ये वाला क्वेश्चन भी मैं तुम्हें पहले करवा चुका हूँ, तुम्हें याद तो नहीं होगा, भूल गए होगे. Still I am showing you. These are the question that I have started with. भूल गए?
बस याद है ऐसे सर.
याद है तो पूछ कैसे रहे हो? भूल गए हो? Then go for this. Find out its equivalent DFA. And don't think that whatever you have designed there, the same DFA will come. You have to use the conversion steps that I need. Be quick to do it. Then I will explain. जल्दी जल्दी. Then Shikhar Swarup,
Yes, sir.
what is the epsilon closure of Q0?
Q0 and Q1.
Wrong. What I told
Sorry,
you, what do you
Q1
know?
only. Q1. But it's the state
मैं
itself, na, sir, Q0.
क्या लिखा था वही तो पूछ रहा हूँ. Is the state itself
And the state which is approaching with the help of epsilon.
not approaching, and the states which are reachable by providing only epsilon.
Epsilon. Yes, sir.
तो क्या होगा? Q0 को क्या epsilon closure निकलेगा? तो पहले कौन सा स्टेट आया?
Q0.
Then epsilon से कहाँ जा रहा हूँ?
Q1.
Then
Q2.
तो क्या आया?
तीनों आ गया, सर.
तीनों आएगा. तीनों आ गया है. ज्यादा हो रहा है, तुम निकाल दे रहे हो क्या?
नो सर,
जो आएगा.
लेकिन सर Q2 तो Q1 से जा रहे हैं ना हम लोग.
तुम इनपुट Q0 में सोचो एप्सिलॉन दिए तो कहाँ पहुंचेगा?
Q1 में पहुंचेगा सर.
तो एप्सिलॉन के साथ एप्सिलॉन मिलेगा तो क्या होगा? वही
तो Q2
एप्सिलॉन
में
होगा
पहुंच
कि नहीं?
जाएगा. यस
हाँ.
सर, यस सर.
मतलब कुछ नहीं दे रहे हो मगर Q1 भी पहुंच रहे हो Q2 भी पहुंच रहे हो. That means here the epsilon closure of Q0 is Q0, Q1 and
Q1
Q2.
and Q2.
Understand?
Okay,
Q0
sir.
itself and with epsilon input it is Q1 and Q2. Shikhar, then tell me what is the epsilon closure of Q1?
Q1 and Q2.
Q1 and Q2. Epsilon closure of Q2 is?
Q2 itself.
Very good. Then this is the epsilon closure I found out. Epsilon closure of Q0 is Q0, Q1, Q2. Epsilon closure of Q1 is Q1, Q2. And epsilon closure of Q2 is only Q2. Now my work is to convert this into DFA. Now my work is to convert this into DFA. Then for the DFA, what will be the initial state? अभी बोलो मैंने क्या बोला था? What is the initial state of DFA?
Initial state of NFA.
वही बोला था. सुन नहीं रहे हो क्या?
Sir, epsilon closure.
Epsilon closure of the initial state of the NFA closure.
Yeah. This is epsilon closure of initial state of NFA, not initial state of NFA. Okay. Then what is the initial state of NFA? NFA का initial state क्या था? Q0.
Q0,
finding-
Q1, Q2.
Then finding its epsilon closure. Epsilon closure of Q0 is Q0, Q1 and Q2. And hence, this is the initial state of the DFA. Then going for DFA, initial state, let its name is A. I have given a new name. A with a 0. That is Q0, Q1, Q2 with a 0. You can see Q0, Q1, Q2 with a 0. Q1 no 0, Q2 no 0. That is why Q0 with a 0 is Q0. That means I am getting Q0. Now epsilon closure of Q0 is Q0, Q1, Q2. That is Q0 with a 0 is Q0. Q1 with a 0 is 5. Q2 with a 0 is 5. That is 0, Q0 union 5. That is Q0 and its epsilon closure is Q0, Q1, Q2. And as you can see, already I have this state whose name is A. Yes or no? Yes or no? Q0, Q1, Q2 एक स्टेट मिल चुका है कि नहीं? उसका नाम क्या था? A दिया था मैं. तो इसे
Yes, sir.
कोई
Yes,
नहीं.
sir.
That's why I have not given any new name to this. Then moving for A1, what I am saying, here the epsilon closure of del Q0, Q1, Q2 with a 1. That is Q0 with a 1, 5. Q1 with a 1, Q1, and Q2 with a 1, 5. That means here I am getting Q1 and its epsilon closure is Q1, Q2. And now I am getting a new element. You can see I had a previous element Q0, Q1, Q2. And now I am getting Q1, Q2. This is something different. And that's why I'm giving a new name to it known as D. Similarly, moving for A with a 2, Q0, Q1 with a 2, only Q2, 2 is Q2, others are 5. And hence, epsilon closure of Q2 is Q2, and I have given a new name to it as C. As I got two new states B and C, I have to find out the transitions for B and C. Then moving for the partial DFA, I got this much. Here you can see A with a 0, A with a 1, B, A with a 2, C, A with a 0, A with a 1, B, and A with a 2, C. Then now moving for the new states B and C. B with a 0, that means Q1, Q2 with a 0, Q1 with a 0, it is 5, Q2 with a 0, it is 5, and hence it is 5. I will name it as a dead set or D. B with a 1 means Q1, Q2 with a 1, Q1 with a 1 and Q2 with a 1. That is Q1 with a 1 is Q1 and Q2 with a 1 is 5. that is Q1 union phi, that is Q1, and by the result I am getting Q1, Q2. It is the state B itself. I don't have to give a new name. Similarly, B with a 2, I am going for Q1, Q2 with 2, Q1 with a 2 is phi, Q2 with a 2 is Q2, and the epsilon closure of Q2 is Q2 itself. And the state is previously there here with me. I have given the name of Q2 is C, and that's why it is the state C. And now going for the partial df, I can say B with a 0, phi, B with a 1, B, B with a 0. I have not shown, you can design a phi state or dead state here. B with a 1, B, B with a 2, C, over. Again, this is partial because C's transition is not defined. Then going for C. C with a 0 means epsilon closure of Q2 with a 0. Q2 with a 0, phi, that's why it is phi. Q2 with a 1, it is also phi. That's why their epsilon closure is also phi. And Q2 with a 0 is Q2. And the name of Q2 is C previously. Now it is C. And now I have gone for all the states and no new state is remaining, and hence the TFA is complete now. And only one thing missing, that is called the dead state or dummy state. You can design it by yourself. What are the transitions missing? Those will go to the dummy state. That is for this B 0 and from C 0 1. I can go for a state here known as the D. And for D there is a self loop with 0 1, as you know it. Now this is the question that you have to solve now. किसी को कुछ समझ में प्रॉब्लम हुआ? Any doubt from anyone else? Rahul Senapati,
No, sir.
Yes, sir.
understood?
Yes, sir.
Then tell me here, for this question, what is the epsilon closures?
Sir, from Q1 it will be Q1 and Q3.
Very good.
Q3 to Q2. Sir, that's it, I think.
तो बाकी स्टेट्स का एप्सिलॉन क्लोजर नहीं निकलेगा?
ये सर वो सब कर रहे हैं, थोड़ा टाइम लगेगा.
टाइम क्या लगा? देख के बोल सकते हो 2 से कोई एप्सिलॉन ट्रांजिशन है?
नो सर.
तो इसका एप्सिलॉन क्लोजर क्या होगा?
पाई.
पाई नहीं होगा, 2 होगा. The state itself and the states reachable from it with epsilon. ये पहले क्यों 1 लिए थे? 1 and state reachable is 3. तो इसीलिए 1 का निकला 1 3. 2 का कोई एप्सिलॉन नहीं है ट्रांजिशन, इसलिए 2 का 2 हुआ. 3 का?
सर 3 का 1 3.
1 3 नहीं होगा. 3 से क्या कोई 3 का only 3 ही होगा, only. Okay.
Yes,
These
sir.
are the epsilon closures. Then here we can go for some more differences, but now, okay, I'm just going for it, then I will go for the exam. Then you can see this is the NFA. Tell me, what is the maximum number of states possible in its DFA? Rahul, तुम्हें ही पूछ रहा हूँ. What is the maximum number of states possible if I'll convert it into a DFA? Rahul Senapati, तुम्हें पूछ रहा हूँ, आंसर दो. What is the maximum number of states possible if I'll convert this NFA into
Sir.
DFA? Sir, उसके बाद?
Sir, 8.
8, very good. And what will be those 8 states? क्या क्या हो सकते हैं?
क्या 8 states Q1 Q2 Q3
अरे पावर सेट निकाल दो, क्या इतना सोच रहे हो? 5 1 2 3 1 2 1 3 2 3 1 2 3 क्या इतना सोच रहे हो? लाइटली लो, इतना टेंशन लेने का जरूरत नहीं है. Then these are the states possible. Yes or no? If I'll convert this convert this into DFA, then the DFA will contain this much of states, which is possible. Sigma is a bit. This is the transition function I got. And I can do it in the same way. That is, here I have shown you all the states. But in some cases, some states may be unreachable that you know before. Now your work is to convert it into DFA, do it by yourself. And the exam link is there in your chat box.
सर ये जो
वो
सारा इसको तो निकालने के लिए कुछ
B and epsilon. All other things remain same. You do it now, you will show me the result, then you can leave. But before that, attend the exam. You have very less time for it, maximum 3 minutes to 5 minutes. Just go for it. The link is shared with you. Be quick to attend it. Be quick. जल्दी करो.
सर अटेंडेंस है कि
अटेंडेंस लूंगा, इसी बीच ले लेता हूँ। अच्छा है। अभिजीत, अंकित,
प्रेजेंट सर। सर अंकित प्रेजेंट।
अभिजीत प्रेजेंट।
हेलो हेलो सर। सर
हाँ
अंकित
हेलो,
प्रेजेंट।
हाँ ले लिया attendance। पार्थ,
Present, sir.
तान्या,
Present, sir.
आशुतोष,
Yes, sir.
निखिल,
प्रेजेंट सर।
राहुल,
यस सर प्रेजेंट।
आयुष्मान, चंद्रकांत,
Present, sir.
आतिश,
यस सर।
ज्योतिष, सत्युष,
प्रेजेंट सर।
अनूप,
प्रेजेंट सर।
हरिओम, पृथ्वीराज और संदीप, त्रिविक्रम,
Present, sir.
प्रीति,
यस सर।
राजीव,
प्रेजेंट सर।
विकृति,
Present, sir.
संबित,
प्रेजेंट सर।
कृष्णा।
प्रेजेंट सर।
Those who are giving attendance don't leave the meeting. Rahul,
प्रेजेंट सर।
Divya,
प्रेजेंट सर।
Kakon,
Present, sir.
Asutosh, Devajyoti,
प्रेजेंट सर।
Shikhar,
Present, sir.
Amya,
प्रेजेंट सर।
Shirsak,
प्रेजेंट सर।
Ananya,
Present, sir.
Shruti Namra,
Present, sir.
Khushi,
Present, sir.
Yar, Nikita, Abhi,
Present, sir.
सर सिब्लू
सर
प्रेजेंट।
निहार रंजन कोहली
कौन बोल
प्रेजेंट।
रहे हो?
हेलो
कौन?
सर निहार रंजन कोहली प्रेजेंट।
नहीं सोई पड़ते डाकुची दिन थर कौन
नहीं सर सर
शिवलू
सिब्लू दास प्रेजेंट। सर प्रेजेंट।
Sir Nikita present.
डाकुची सोई पड़ते ना कौन?
Sir Rehan
सर
Khan
आपका आवाज
कृष्णा,
अच्छी लेने।
कृष्णा, कृष्णा, अभी,
Present, sir.
अंजलि,
Present, sir.
अंजलि,
Present, sir.
प्रियव्रत,
प्रेजेंट सर।
दिव्या,
प्रेजेंट सर।
अलीसा, आदित्य, दीक्षा, अमृत,
Present, sir.
राजेश, सत्यनारायण,
प्रेजेंट सर।
सज्जल,
यस सर।
रूपम,
यस सर।
Sir Rehan Khan present. Hello.
हाँ रुको वेट करो, रजिस्ट्रेशन नंबर बोलो।
339.
339. Okay.
Thank you.
कितने रजिस्ट्रेशन नंबर का? Two double. Present अच्छी already. Okay. Then return back.
So
Return
Jyotish
back.
Naik, sir.
Listen. Don't leave the meeting. Listen. Here, this question you have to solve. But before that, I am showing you something else. This is about your Wednesday class. That is the PSS class. Okay. As you know, in the PSS class, your work is to submit the scanned copies. You know or not? Hello.
Yes, sir.
You
Yes, sir.
then
Yes, sir.
this PSS class you will get only 5 minutes. That's why keep your scanned copies ready. Okay, sir. Saying मगर doing nothing. इसीलिए मैं बोल रहा हूँ क्वेश्चन बता दे रहा हूँ उसका आंसर बना के रखना ठीक है
Yes, sir. Question बताओ.
क्योंकि नेक्स्ट मैं इसमें टाइम दूंगा नहीं आई विल नॉट गिव यू एनी टाइम जो क्वेश्चंस घर में बनाने के लिए दे रहा हूँ उसी क्वेश्चन को मैं तुम्हें आज यू नो दैट यू हैव टू डू ऑल दोस क्वेश्चंस एंड कीप प्रिपेयर्ड सो दैट आई कैन take the results immediately. The screen is visible to you.
Yes, sir. Yes, sir.
You can see the question number 1 is you have to construct a NF epsilon over sigma ABC and the language is a to the power I, b to the power j, c to the power k, ijk greater than or equal to 0. And you have to find its equivalent DFA. Question number 1. Question number 2 क्या है? W such that W contains A as the third symbol from right. For that, you have to design a NFA and convert it into DFA. Question number 3. You have to draw an NFA that accepts all strings which does not contain the substring 110. Which does not contain the substring 110. Okay. Question number 4. You have to find out the DFA for this NFA. Okay. This is question number 5. You have to find out the DFA for this NFA. These are the 5 questions. These are in your copies. These are already there in your copies. Only to make you remember, I am showing you. Okay. Then for this class, I can say we have discussed about how to go for converting the epsilon NFS into DFS. Okay.
Yes, sir.
And these questions that I told you must be ready within that day. And this is another practice exercise for you. Write down these questions, then you can leave. Thank you. And also wish you a happy Lakshmi Puja.
Thank you, sir.
Have a nice day and write the question.
Thank you, sir.